Rocket Lab, the global leader small satellite launching private space agency like SpaceX. This company is founded in 2006 by a New Zealand engineer Peter Burke. It has a headquarters in California, but all its official work are maintained from New Zealand. Its orbital launching vehicle, the Electron rocket that carries satellites to its orbit. Now you can see the main part of the rocket, Rutherford engine, which is world first electric pump-fed rocket engine. These videos explore the all technical aspects of Rutherford engine and the flight history of this engine. To get these types of engineering and rocket science related video, please subscribe our channel. Rutherford is a nuclear propeller rocket engine named after the famous New Zealand bronze scientist Ernest Rutherford. The engine fuel RP1 is a very refined kerosene fuel and the engine weight is almost 35 kg. The engine is capable of delivering thrust 25 kN and the thrust and weight ratio is 72.8. The engine can give specific impulse of 311 seconds. Electron rocket uses cluster of 9 identical Rutherford engine on first stage and one vacuum optimized barrier with more extended nozzle on second stage. The vacuum optimized version of the engine produces thrust of 26 kN with specific impulse of 343 seconds. The Rutherford engine is world first electric pump-fed engine. The most rocket engine rely on turbopump to supply fuel and oxidizer to the main combustion chamber. In this chart, we can show the full flow staged combustion cycle consists of two turbopump to pressurize and inject the fuel and oxidizer to the combustion chamber. Both turbopump are powered by separate pre-burners which combust a portion of fuel and oxidizer to produce the energy required to the turbopumps. Electric pump-fed engine instead of liquid propeller, the pumps are powered by the electric motor with lithium polymer batteries. An inverter converts the DC electricity to the AC needed by the motor. The motor derives oxygen and fuel turbopumps which pressurize the propeller before pushing it to the combustion chamber. Liquid oxygen derived directly into the combustion chamber while fuel is circulated. Before being fed into the combustion chamber, the Rutherford engine uses dual brushless DC electric motors and lithium polymer batteries. The motor generates power of 37 kW, was spinning at 42,000 rpm. The first stage battery, which powers the pump's 9 engines simultaneously, can provide power over 1 megawatt.
The electric turbopump cycle is a totally different way to pump propellants into the rocket engine. So we carry about 1 megawatt where the battery is on board, and we have these little electric turbopumps. They're about the size of a Coke can, not much bigger than a Coke can. They spin at 42,000 RPM, and each one of those Coke can-sized turbopumps produces about the same amount of horsepower as your average family car. And we have 20 of them on the rocket.
Let's compare the Rutherford engine to a traditional rocket engine. Rutherford cuts down on much complex turbo machinery and plumbing typically required for gas generator engine. It is simpler to build a conventional engine. The electric pump-fed system, it eliminates the needs of extra tubes and valves which adds more weight to the engine and frequently the same source of engine failure. In traditional engine, the pre-burner combustion must be timed with engine operation, but Rutherford engine follows radically different approach using brushless DC motor and lithium battery cells completely eliminates the thermodynamics problem. But even with all this advantage, why are the electric pump-fed engines are not popular in rocket science or rocket industry? The problem is energy density of the battery is too low in the past, but according to Peter Burke, there have been many revolutionary development in battery technology in this year that allows to go electric turbopumps. It claimed that electric motor improve efficiency from 50% of standard gas generation from 95%. However, the battery pack raises weight of the complete engine and poses energy conventional challenge. Thrust chamber, injector, turbo pumps, propellant valves of engine are all made by electron beam melting technology. Electron beam melting is an advanced form of 3D printing, where metal powder is completely fused layer by layer with an electron beam in a high vacuum. In this process, the metal powder is first loaded into the machine. The build chamber is closed and vacuumed to create a clean and controlled environment. A powder layering system then evenly distributed thin layer of powder in a built area. A powerful electron beams hit the powder bed to an optimal temperature of around 1000 degrees Celsius. As each layer is completed, the build is lowered and a fresh layer of built powder is raked over. The process repeats and repeats, then the final product is ready. They uses Einhell and titanium powder for 3D printing component.
According to Peter Beck, Rocket Lab can print an engine within 24 hours, and they plan to launch a rocket every 72 hours.
3D print these rocket engines. So each one of these engines is 3D printed out of Inconel superalloy, and right now we can print around about one engine every 24 hours.
Rutherford has the most 3D printed components of any rocket engine in the world. Rutherford engines are manufactured in Rocket Lab headquarters in California. They are shipped to the Rocket Lab New Zealand facilities for testing before the integrating with launching vehicle. Rocket Lab began development on the Rutherford engine in 2013. Within same year, Rutherford was test fired for first time, marking the beginning of a new generation in rocket propulsion. Here you can see the report of Rocket Lab that says the test was successful. After 2 years of test, on 14th April 2015, at the 31st Space Combustion in Colorado, Peter Berg unveiled the Rutherford engine. After completing more than 200 engines not fired at a part of qualification at 21st March 2016, Rocket Lab announced that the Rutherford engine is qualified for first flight, and they look to manufacture the engine quantity for both test and commercial flight. First flight of the engine happened on 25th May 2017. The Electron rocket on the no payloads lifted off Rocket Lab Launching Complex 1 situated in Mia, New Zealand. The rocket successfully done its first firing separation, but after reaching at altitude of around 224 km, the rocket telemetry signal was lost. The rocket destroyed. After back-to-back failure, it succeeded. On 31st January 2018, the Rocket Lab announced that the engine has completed the 500 test fire in test stand. It is great news. The milestone firing brought the Rutherford engine series of 19,000 C of commutative flying. At 8 July 2019, Rocket Lab announced that it has produced 100 flight ready in headquarters for fly and conducted more than 850 successful engine tests in fires. हिंदी में एक बात कहा जाता है कि कोशिश करने वालों की कभी हार नहीं होती. वही बात रॉकेट लैब ने फिर एक बार साबित कर दिया. That's why as of September 2020, Electron has flown 14 times, making the count of total flown Rutherford engine 140. Do you want to be a rocket engineer like Elon Musk or Peter Berg? What do you think about non-conventional rocket engine? Please comment on comment box and subscribe our channel to get these types of rocket science related video in future. Thank you for watching this video.